Yeah, good morning to all. Today, let us focus on one more complex object and we'll try to draw front view, top view, and side view of that complex object. Before that, we will like to see first of all a simple concept of a vertical cylinder. Suppose there is a vertical cylinder as you can see here. So let me try to draw a vertical cylinder. Yeah, so here I have drawn a vertical cylinder. So if you say that suppose observer X is here, and if you're looking at the cylinder, you can see the boundary of the cylinder, right? So the boundary of the cylinder can be seen. The circular edge will be seen as a straight line. Okay. Even the bottom circular edge will be seen as a straight line. So overall in the front view, this cylinder will be seen as a rectangle and top view will be seen as a circle. But now suppose if I say that this is the center of the circle cylinder, let this be the center of the cylinder. Now if I cut the cylinder slightly from the left and slightly from the right, let us cut like this. So say I have cut the cylinder and the dark portion what is shown is retained. The light portion is removed. Okay. So let us try to draw a cut cylinder. Yeah, so here we have drawn a cylinder which is cut from both the ends. Okay. Now if you try to look in the front view, what I want all of you to recognize is in the front view, this dimension, if you compare from here to here, is it equal to the diameter of the cylinder? Is it more or is it less? So if you look at the length of this line and if you compare the length of the line along the diameter, you will come to know that they are unequal. The diametrical line is the largest or the biggest line, and as you move away from the center, the length of the line goes on decreasing. So this length is smaller compared to the diametrical line. So point to be understood is in the front view, you can see the boundary of the cylinder, no doubt. The green boundary will be seen. Apart from that, this black line will also be seen separately. So there are two edges what you can see separately. Let us say that this dimension from here to here, suppose this dimension from here to here, suppose it is say 20 millimeter. Okay. Now how will you draw the front view, top view? Let us start. So to start with the top view, first of all, so in the top view, if you look at this circular edge, what I am highlighting, if you look at the bottom circular edge, the second one, what I am highlighting, the third one over here, and the fourth might be slightly behind, somewhere behind. If you join all these four circular edges, you can see one complete circle. So if you try to draw the top view of this cylinder, it's a complete circle, correct? And we already discussed that whenever you find a cylinder in an object, always start with that view from where the cylinder is seen as a circle. So here you can see circle from the top view. So in the top view, if I draw a circle like this, correct? Let me draw a circle. But apart from the circle in the top view, you can see surface A, you can see the bottom surface B on both the sides. So if you look at the center of the circle, now see this dimension is how much? 20. So from line of symmetry it is 10 each. So if I move 10 up and 10 down, you'll get such two lines. So remember you have to look from this side. This is your front view. So top view has to be from here. So both these lines will seem to be horizontal, not vertical. Sometimes it happens that by mistake student draw the top view like this, which is wrong. They have just changed the orientation. So you should not watch from, it is important from where you are watching. You should not watch from the other side. In fact, you should watch from where X is given. So since X is given from here, you have to watch from this side. So these two will be the horizontal lines which is 20 millimeter apart. So that is how the top view appears like. Now see, because this is the top view, we know that top view is kept on HP. So this plane is the horizontal plane and vertical plane is just coming up. So you have to visualize that. And observer is here. This is his head and this is his shoulder. So observer is looking from this side. Same thing here also, you are the observer. So you are standing here. Okay, you are standing here. And the top view of your head is a circle. And that circle is over here. And apart from that, there are shoulders. So these are the two shoulders. And you are watching from this side. Now let us draw the front view of this. So first of all, in the front view, this green line can be seen as the boundary of the cylinder on both these sides. So in this diagram, the boundary of the cylinder first and second is here. So when you project this up, yeah, you can see the boundary of the cylinder like this. And you can darken this. So now we are drawing the front view, which is always drawn on the vertical plane. Okay, so that is how the front view rectangle is drawn. But apart from that, I can also see an additional dark edge, which is away from here. This dimension is not given. And it is neither a printing mistake. So if you try to visualize this edge from the top view, you can get the answer. So try to find out in the top view, where is this edge? Yes, so that edge is from here. It is this one, right? It is from here to here. See the same edge. This and this are almost same. So that edge is over here. So if you project the inner edge, you will get two lines inside. Correct? Now suppose the height of this edge is suppose 40 millimeter. Because you can, in the front view, you can see rectangle Roman 1 separately. So if you come down by 40 from here, from top, if you come down by 40, and if you darken this, see, darken these three sides. So that is how the cylinder can be seen. So the gap between these two lines, actually it's a radial surface. So if you look in the front view, the gap between the black line, vertical, and the green line is nothing but the radial surface. It's a curved surface. So this portion is actually a curved surface all throughout. Now if you look at this diagram thoroughly, you can see that the axis of the cylinder still exists. So we need to draw an axis over here. Okay. So that is how this length can be found. So as I told you before also, there are many things in engineering graphics which can be found only after you draw. So only after completing the drawing, we come to know this side, this dimension. So this dimension you cannot find out mathematically, not geometrically. You need to draw and find out. Okay. So after you've drawn it, you come to know that this edge is already drawn in the top view, and by projection you'll get the dimension. Okay, so this was the basic concept what I just wanted to brush up before you start with the new question. So this is today's question what you're going to solve. You're asked to draw front view, top view and right hand side view. So to begin with, we know that in first angle method of projection, right hand side view is always drawn to the left of the front view. So if you're drawing front view over here, if you're drawing top view below it, then left hand side view should be drawn, or sorry, right hand side view should be drawn to the left of the front view. So this is the right hand side view. Up till now we have seen the numericals, or we have solved the questions where the side view was left hand side view to the right of the front view, but now it is the other way around. So the only difference is after you prepare after you prepare two box, front view and top view, from this corner of the front view box, now you should draw 45-degree line, and then you have to project like this. So it is a mirror image of what you're doing till now. So before proceeding, let us see the overall length, width and height of the object. So if you look along x direction, the length is 90, width is 60, and if you look at the height of the object, see they are given 32 over here. So this is the base of the object, or you can say platform of the object. So this trapezium type is called as the platform, and the above part is the cylinder what we have seen just now. So if you add the height of the platform and the cylinder, you will get the total height of the object. So 32 plus 54 is 86. So 86 is the height of the object. So let us write down here length of the object 90, height 86 and width of the object is 60. So based on that, let us start preparing 3 box what is required. So we should know that the orientation will be somewhat like this. Front view should be here, top view should be below, and left and right hand side view should be on the left of the front view. Okay, so front view, top view and side view. So first of all, let me draw a vertical line. So I'll take out that 0.5 pencil. Okay, so from here we'll draw a vertical line. Okay, and roughly from here so I have drawn 2 light lines which are perpendicular. Okay, and this light line, the intersection of these 2 lines will be my starting point from where I'm supposed to measure and draw. Now we are supposed to draw our front view box over here. The front view box is going to lie somewhere here, and front view comprises of length and height. So length of the object is 90 and height is 86. So we need to measure 90 and 86. So let us measure 90. So from here I marked 90, and for 86 I'll align the roller scale, roll and slide, and draw a vertical line. I'll just extend this further. So all of you should remember that box should be drawn as light as possible because that is not the actual object. So we are just reserving spaces for various views. So length is 90 and now I need to mark height as 86. So from here I will mark height as 86. Okay, then I will roll and draw. Okay, so here I need to verify whether it is 86. Yes, almost 86. And from here we will extend the light line till the end. Okay, so that is how the box for the front view is being reserved. So within this box front view should lie. We know that the safe gap between 2 views is 20 millimeters. So let us mark 20 quickly. And from here if you roll this down, so this is our 20 millimeter. So I've drawn a light line of 20 millimeter. Now from this 20 over here we need to mark width of the object so that we can get the top view box. So top view comprises of length and width. Length is already 90, we need not measure again. Width is 60 millimeter. So from here I need to mark 60. Okay, so once 60 is being marked, from here I need to roll down and draw a light line of 60 millimeter. Let me extend this further. Okay, so this is the front view box what is ready. This is the top view box what we had drawn just now. Now they have asked us to draw right hand side view which will be on the left of the front view. So this is the front view box. So on the left side you have to draw the right hand side view. So what we will be doing is from this front view box, if you look at the bottom left corner from here, we will draw 45-degree line. Okay, so I will use a protractor, and from here 45-degree I'll mark a point. After that I'll align both the points together and I will draw a medium dark line Okay, so now wherever this width, see this width is 60. Let us verify once again. Yes, this width is 60. So wherever this width intersects 45-degree line, you can see that it intersects here and it intersects here. So if you can project this up, you'll automatically get 20 millimeter also, and you'll get the side view box also. So let us align with this line, and we will draw a light line from here. Also from this side we will align. And that is how our side view box is prepared. Okay, so our side view box is ready. So if I try to find the width of the side view, it is showing 60 approximately, and the height is approximately 86. So it's almost what is needed. Okay, now to begin with this solution, there is one more technique of drawing the front view, top view, and side view. Let us see what is that. So the technique is that you may divide this object into two halves. The above half is a cylinder and the lower half is a base or a platform. So even if a student draws front view, top view and side view of the base first, and then top view, front view and side view top view, front view and side view of the cylinder first, and then if you draw top view, front view and side view of the base, or vice versa, then also is okay. So that technique is also acceptable. So what I want to say is, instead of drawing the front view of the entire object together, you may draw front view of the cylinder alone, top view of the cylinder, side view of the cylinder. Once all the three views are over, you can draw front view, top view and side view of the platform separately. So let us try this method out today. So first we'll focus on cylinder. See, now observer is along this side, right, X. And when you look in the top view, this circular edge, as we have discussed, this circular edge, the bottom edge, and this behind, if you join all these four circles, you're going to get a complete circle. And diameter shown in the question is how much? 50. And moreover, if you look on this side of the platform, see, this cylinder is in mesh with the edge of the platform, and you can see a gap over here, same gap is on the other side. So this clearly resembles that this cylinder is kept in the center of the top view. So whatever is the top view area, the cylinder is centrally spaced. So if you want to draw a circle of diameter 50, it should lie somewhere midway on the top view box. So let us try to draw a circle of diameter 50. So in the top view box over here, when I try to draw the cylinder, our first job is to mark the midpoint of this box. So you can see that this is 60, half of 60 is 30, and this length is 90, half of 90 is 45. So now if you try to draw two light lines of symmetry, so from here if I align, I'll also extend this up, it will be required further, and from here if I roll this down, so the intersection of these two lines is nothing but the center of the cylinder, and from here we can draw a circle of diameter 50. Okay, so once again, if you look at this diagram or this object, this curved edge plus the bottom curve plus this curve and the behind curve, if you add all these four curvatures, you're going to get a circle of diameter 50, and that too is centrally spaced because you can see this gap on both the sides, and here it meshes with the edge of the platform, so it is symmetrically spaced, it can be understood. So now let us draw a circle of radius 25, diameter 50. So here I have the compass, I will set 25 millimeters. So I always reverse the scale like this, because on the rear side the compass needle rests properly on the calibrations. So I will mark 25, I will set 25 millimeter in the compass, So that's what I've done. And from this center, let us draw a circle of radius 25, diameter 50, and that too dark because it is an object line. So I have drawn this dark, you can see here. So you have to trace multiple times. Whenever you draw a circle, to get it dark, tracing twice will not help. You need to trace multiple times to get a dark and uniform circle. Okay, once this circle is ready, now in the front view, if you observe, see we are drawing the top view right now, correct? So in the top view, when you observe, you can see first, second and third line as one single line, correct? So these three lines in the top view. So if you compress the object from the top, if you assume the object is like a sponge, if the object is like a sponge, and if you compress from top, these three lines, first, second and third, will coincide together and give you one single line. And this is on both the sides. And the gap between these two lines is 20 millimeter. So it is clear that from line of symmetry, it is 10 on either side. Now the doubt arises is, should I mark that 10 to the left and right of the line, or should I mark 10 up and down of the line? Which one is better? So instead of looking for better, actually, you should look along x direction, and in the top view you should find out which one is correct. So if you stand here along x, and if you look in the top view, both these lines are horizontal. So here you have to draw horizontal line 10 up and 10 down. But by mistake, if you stand here and look from this side, the same line will appear vertical. But this is not the correct way to look at, because you always look along x direction. So from x direction, if you look at the top view, both these lines are horizontal, and that too 10 up and 10 down. So I need to mark 10 up and 10 down. So here I have marked 10 up and 10 down. Now next part is, after you mark 10 up and 10 down, now is the length of these lines equal to diameter or less than diameter? So obviously there is a circle here, correct? So because of this curvature, the length of this line is being reduced a bit. So this length is not equal to diameter, it is less than diameter. And you will get the length of this line only after you draw a line to cut the circle. So if you look here, after I mark 10 up and 10 down, if I line over here and if I roll down, I need to draw this dark, as you can see here, correct? And then I'll roll up and draw one more line dark. See, like this. So the length of this line can be determined easily only after you're drawn. You cannot find mathematically. So that is the same line. Okay, apart from that, stand along x direction and look in the top view. You can see two more lines which is 24 apart. So from line of symmetry, it is 12 on either side, and that should cut this thickness of 20 mm. So I can see two more edges, or you can see that at the bottom there is a flat surface what can be seen, which is 24 wide. So from here, from the vertical line of symmetry, I need to mark 12 right and 12 left. Okay, and then from here, if I slide this, I will get one part, and over here I'll get another part. So now if you look at the diagram overall, you can see many surfaces. First one is this, second is the opposite side, third is 1, 2 and 3. So if you look at this diagram, look at this part. It's a straight line, curve, straight line. Same thing is here, straight line, curve, straight line, straight line. So that portion is this one. Let this be A. So that A is over here. Then B is the bottom part, isn't it? A rectangle. So that rectangle is the middle one. C is the other half. This is C. D is the bottom part. D is here. E is on the other side. So that is how various surfaces we have drawn over here. Okay, so hope this portion is clear. Now before we complete the top view, let us complete the front view of the cylinder first of all. So all of you look in the front view carefully. Apart from this vertical edge, you can at the max see the boundary of the cylinder. So this curved portion will be seen in the front view. To stand in the front, this vertical edge will be seen, no doubt. But apart from that, at the max you can see the diameter of the, or you can say the boundary line of the cylinder, isn't it? So now what you have to do is that, let us first try to draw this boundary which is 54 millimeter high. Okay, so this boundary is 54 millimeter high. We'll try to draw this first. Okay, and if you look in the top view, the boundary resembles this point of C, that is the peak point of C and A. So in the diagram, if you look at this diagram what you're drawn, actually observe looking from this side. Okay, so this curve can be seen. This curve is same as this one, both are same. So if you stand and look here, this curvature is same as this one. So at the max you can see up to this boundary and the other boundary over here. So from here, if I project this point, same way on the other side C, let me project this point up. So both these boundaries are projected up. Okay, let me extend the line of symmetry. Yeah, so I am extending the line of symmetry one. Yeah, so we'll extend the lines a bit above. Yeah, so that is how this cylinder we are projected up. So once cylinder C is being projected, sorry not C, this cylinder is being projected, so the boundaries of A and C were projected up, and as per the question the height of the cylinder is 54. So you can see this boundary well up to 54 millimeter, isn't it? And then the bottom edge will be seen as a straight line. The circular edge from the front will be seen as a straight line, and you can also see this boundary. So let us darken the boundary up to 54 mm. So I will align this with A, and up to 54 millimeter I will darken this boundary. So we'll do this on both the sides. Up to 54 we need to darken it. Then this bottom edge I will close down because the circular edge will be seen as a straight line. So I hope that these three lines are clear what it is meant for. So it is for this cylinder, then the bottom circular edge, and this top one. Okay, after this next part you can see there is a cutout over here. This cutout is 21 mm deep, so dimension is 21. So this cutout is 21 millimeter deep. So let me show you separately. Yeah, so you can see the dimension 21 over here. So this cutout is 21 millimeter deep, and the width of this cutout is 24 millimeter. But have we drawn this 24 in the top view? We need to search. So see this dimension B, this is 24 millimeter. Okay, so the same slot of 24 we have already drawn here. So if I extend this to 24 up, will I get a cutout over here? Only thing is that you need to produce it till depth of 21. So let me align the roller scale and project this A. So projection is compulsory to learn orthographic. So you should know what to project and when to project. Okay, now after this projection is done, so now we can come down by 21 from this point and draw the slot. So let us mark 21 millimeter. Okay, so from here we will darken this 21. We'll come down. So see, by mistake instead of 21 you don't mark 12 by mistake. So there are many drafting errors possible. You should be careful while marking each and every point. So I have drawn the three edges. So as per the question, in the front view when you observe, you need to close this straight by straight line. So actually it's a combination of straight edge and a circular edge. If you look them together, it's one single line. So this straight edge and a small circular edge will combinedly give you one single line, and that single line is over here. So hope this part is clear. So this cutout we are already drawn. Now the next important part what I wanted to discuss is, apart from this cutout you can also see this vertical edge. because the line what you've drawn, this line is actually the boundary of the cylinder. So this line resembles the boundary of the cylinder, but this vertical edge is a separate edge. Okay, so both these lines are separated by a circular surface. So this edge we need to draw, and the depth is 38 millimeter. So the height of this line is how much? 38. But how will you get, or how will you locate this point or this edge? How will you locate? So let us ask to the top view. If you look in the top view, this edge is seen as a point, isn't it? So try to identify or locate this point in the top view. So if you compare this diagram in the top view, that point is, observe thoroughly, that point is this one. See, try to understand this point and this are one and the same. So if you can project this point, you will get an edge. Same way on the other side at A, this is that point. So when you look in the front view from this side, this straight edge, okay, you can see that this straight edge is same as this one, isn't it? So if you want the distance between these two lines, you need to project these 2 points. Hope it is clear. Now let us project those 2 points up. So from here we'll align the roller scale and we will project this little bit inside, and here also we'll project this a bit inside. So see, after I projected both the points inside, I am getting 2 light lines inside, correct? But we need not darken this throughout, because as per the question, this edge is only 38 millimeter, so it's given 38. Okay, so if you can't see this clearly, let us see here. Yeah, so this edge is 38 millimeter deep. So we need to move by 38. And now it's clear, 38. Yes, it is 38. So this is 38 millimeter deep. So we need to move down by how much? 38 millimeter. So let us move down by 38 millimeter deep. So from here we'll move down by 38, double trace. Okay, then yeah, roller scale. From here bit raise and draw. And then from this side we'll close this. So if you look at these 2 lines, adjacent lines, the gap is very small, and between these 2 lines the surface is a curved surface. So there is no dark line over here, please remember that. So as per the question, as we discussed in the front view, when you observe, this edge will be seen separately and this edge will be seen separately, and the distance between them is a curved surface. So when you compress the object against the wall, this is how it will look like. Okay, so you can see 2 edges separately over here. Now let us try to analyze the side view of this cylinder. So suppose this is the observer in the front side, and if I try to view the left hand side of the object, so try to visualize this cylinder, what I am highlighting, this surface, the curved surface, how it will look like. So when you draw parallel rays of light, or when you project parallel rays of light, at the max you can see up to the boundary, isn't it? So you can see everything up to the boundary on either side. So up till this boundary everything will be visible, right? And you can see this edge, this vertical edge, this circular edge will be seen as horizontal line. So when you try to project this, and if you draw the side view of this surface, I think it will look like a T shape. Let us see one by one. So this horizontal line what I have drawn is the top circular edge, which will be seen as a line, isn't it? Then these 2 vertical edges till here. So you can see 2 vertical edges like this. So both the vertical edges will be seen as a vertical line. Then this circular edge, if you try to project and draw, it comes out like a shoulder. Then the boundary of the cylinder at the bottom, it looks like this. So that is how, and this straight edge is nothing but the bottom circular edge, which seems to be straight. So that is how the cylinder in the side view of T shape appears to be. Okay, so let us try to reflect this in our example. that is over here. So to start with the side view of this object, so if we look in the side view, let me enlarge a little. Yeah, so in the side view, let us start with the about T surface. So this surface T shape will be seen clearly. So this above edge, that is 20 millimeter, you need to visualize where we have drawn that 20. So in the diagram, this circular edge, what I'm highlighting just now, is same as this one. So when I say right hand side view, visualize that this is the object coming out. So this is your right hand side view. You have to look from here. This is your right hand side view. Correct. Similarly, if this is the front view, your right hand side is from here. So combination of this surface and this one together will give you the side view. So when I say side view, you have to hold this object. Okay, you have to hold this object and turn like this. So when you turn like this, you can see the side view. So now let us start one by one. So in the side view, this circular edge will be seen as a horizontal line, and that is same as this one. So both these points, first and the second point, we need to extend till 45 and project it up. So let us do that. So from here, we need to project this and extend till here. Okay. After that, parallel to this, we need to extend this up again. So you can see that this 20 millimeter width I have transferred to the side view, and in the side view, the topmost edge, what I am doing over here, if I double trace it, you will get that edge over here. So this edge is nothing but, in the side view it is this one, this circular edge, which seems to be straight. Then you can see this vertical edge coming down from both the sides. But what about the height? So because this is the third view, without measuring you should be able to find out this height. So height is always available. Height is always available in the front view, as you know. So if you look in the front view, this height is same as the inner dark line. So inner dark line is same as this edge, isn't it? So by roll and draw, if I lift a little and if I darken this portion, to see how I reach till the required level without measurement. So the moment you start drawing without measurement, you have to understand that you have understood orthographic. So without measurement, if you can draw only by projection, it means you understood the correlation amongst various surfaces. So this straight edge is same as this one. So that is what we have drawn till now. After that, this circular edge will be seen as a horizontal line. So try to find out where is the circular edge we have drawn previously. So better look in the top view. You'll come to know where is the circular edge. So you can see up to here, right? Because this is the boundary of the cylinder. So you can see everything up to here. So this circular edge in the top view is same as this one. See, this is that circular edge, isn't it? So it is nothing but the diameter of the circle on either sides. So if I project this diameter of the circle, let us do that. So when you project the diameter of the circle till 45-degree line, and if you extend, so see, that is how I have projected this. So you need to be careful by using the roller scale. Yeah, so see, I have projected here. So these two shoulders, what is coming out dark is this edge on both sides, and then you can see boundary coming down over here, and this boundary is same as this part. So the shoulders, what has come out, we can darken it over here. This is still the boundary. Now next thing is, after you've drawn this edge, the boundary of the cylinder is visible from the side. You are observing from side, this side you are observing from. So from this side you can see this complete circular boundary, but you can see up to here only. Okay, so what about this height? So height is always available in the front view. So this height is same as this, the distance between these two dark lines. So if I can project this line over here, and now you can see that this T shape, if I join this T shape, if I join, I will get the bottom half. So from here I will join this T shape. I'll extend it on all the sides. And I can darken this. The last and very important thing what is left in the side view is, so try to visualize from side. So when you look from this side, you cannot see a cutout. So whenever there is a cutout, you have to quickly understand that hidden lines has to be there. So hidden line is the one where you need to have a good control. So in the side view, there is a cutout or a rectangle like this. Carefully observe this rectangle. Okay, so let me enlarge a bit and look at this one. So you cannot see this surface from the side. When you look from this side, you cannot see that surface. So this horizontal edge of the surface, if you observe thoroughly, it overlaps with this curve, isn't it? So both of them overlaps. This vertical edge and this vertical edge overlaps with these two extremes. What doesn't overlap? It is this horizontal line, and for that you need to show hidden line. So once you draw hidden line, this area, it resembles the hidden surface. So that is how you have to understand. So coming back here, from the side view, you cannot see this edge, and this edge is 21 millimeter down, and this is nothing but height. So this same 21 we have already drawn here, isn't it? So if I can extend or project this here, I will get a hidden line on this side. So from here, if I align, roll down, come back and draw hidden line like this. Hidden line, it should be drawn neat with a big dash and a small gap. So that is how hidden lines are drawn. It's a combination of big dash and small dash, hidden lines. So based on this, that is how the side view of the cylinder is ready. So we have drawn the three views of the cylinder. This was what I was talking about. If you want to prepare orthographic, there is one more technique. We divide the object into 2 or 3 halves. So here we have divided into 2 halves. The upper half is a cylinder. So we have drawn 3 views of the cylinder, front view, top view, side view. Now we'll shift our focus from cylinder to the base or the platform. So we will draw 3 views of the platform. Okay, and by that you'll understand how the orthographic can be completed.